Hello and welcome to the third video in the new tutorial series on Java 8 for the channel. Today we're going to take a quick look at Lambda functions, what they are, how to use them in a Java context, and how in particular we can use them to write cleaner code. Now, the first bit of this, what Lambdas are. Lambdas are basically, well, not basically, Lambdas are anonymous functions. So if you were to write some function, like this one right here, string foo, you could write the function itself, return I plus space plus j, without providing it the name foo. And the way that you do this, or rather the syntax of Lambda functions in Java, is your arguments followed by an arrow, followed by your code. And in the end of the code, you'll want to return something, but that is implied if there's only one line in the code. You can pass to a Lambda function no arguments. And if it's a single line, you can type it out like this. You can pass it with exactly one argument or any arbitrary number of arguments. And you don't always need to actually type out the types of these arguments. They can be inferred generally from the context of the Lambda function question. But if you want to, you could specify string I, integer j, and double k. Then you have your function. So you might I.append integer dot value of j dot append. Now this wouldn't be the best way to do it, but that dot append double dot value of k. Something along those lines. And I think I got everything. No, there we go. And then you would close this. And that's not actually a valid Lambda function. The reason this isn't a valid Lambda function is because your strings in particular in Java are immutable. So if you try to do this, this will happen, but you'll want to return that. Now the return can be implied since it only has one function, or since there's only one line, one statement in this Lambda function, but best practice generally, I like to keep it in there if I have a multi-line function. If it were just a single line, and none of this, then that would also be valid. Yeah, that would be valid. So it's returning the new string. It's not actually changing I. If you were to say I equals that, well, then you'd have a problem. Okay. So how do we use a Lambda function in Java 8? First, we need to discuss how we might have passed functions around prior to Java 8 happening. So prior to Java 8, the typical way that functions were passed around would be to do something like this. We'd have an interface, functional interface. Whoops, not like that. And this interface would have public function some type of arguments, and that's it. So then, in this case, we're going to say maybe an integer argument, just an integer. So, oh, what are you complaining about? Oh yes, we will want to return something. So let's say it returns an int. So if we wanted to use that function, we might say system.out. We'll go ahead and remove all of this. .println, and we would have new functional interface at override what are you complaining about? Did I do this wrong? New functional interface. What's up here? Oh, no R. Let's try that. And now you don't like this, why? Yes, we have a method body, and we would return arg++. Okay, and then we have this new object, right? And we would then call the function that we just defined, and we would call it with whatever our argument was going to be, and then run it just like that. And this should return for us 6. 5. Oh, yeah. Whoops. Yes, it does in fact return 5, because if I wanted 6, I'd have to say ++arg. So let's try that. That should do exactly what we expect. There you go. So you've kind of passed a function around. You could also say my phi equals, and then we take this entire set here, put it there. Why are you complaining? What's your issue here? Ah, yes. Okay, and then instead of that dot function phi, we'd have my phi. There we go. And this would work exactly the same way. And we get 6 out. So this is how you might pass functions around, and you might take, for instance, instead of having functional interface like this, you might use a predefined functional interface. We'll go ahead and set it up like before. We have println out, and we'll say first we'll get a list of integers from 0 to 10, range from 0 to 10, and in order to get that, we'll want to box it and then collect it, and we'll use collectors to list, import list. Okay, that's good. So then we want to get our out list. So list, well, okay, we'll do it this way. List integer out, and that's going to be some function. So we want to have some filter, right? So say we want the all integers less than 5. So we'll have remove integers greater than amount, and we'll say ints 5. So we'll have to write this filter, and we can go ahead and get rid of this. Whoops. All right, and get rid of that. We have our private static list integer, and we want remove integers greater than amount, and we'll want a list of integers. Oops. List of integers called ints, and we'll want an integer. We'll go ahead and just have a boxed integer amount, and then we define it. So we would say list integer, and this is sort of the pre-Java 8 way, out equals new, and we'll go ahead and do a linked list because we are going to be adding more than accessing in this case. And that's it. So for integer I in ints, we want to do things. Basically, if I greater than amount, whoops, less than or equal to amount, out dot add I. There we go. So we have our list of integers, and this doesn't include any passing functions around or anything. We just have this, and we'll have one to print out. Now this isn't going to get quite what we want. If this were Python, I'm pretty sure it would be sufficient. Missing return state. Oh, return out. All right. Now, if this were Python, oh, actually, it totally works. Well then. I didn't know that println was able to do that. We learn things every day. I was going to do something like this. Dot stream dot so let's see, these are integers, so a map is sufficient. String value of join collect, and collectors dot joining. Yeah, that's what I was going to do, which would have a similar effect, but apparently the print just works. So we'll go ahead and do this. Save it out. So we have our function that acts like a filter. Now, if we wanted to have a more general function, we might say, well, we're going to pass in an int predicate, which is a function that acts on integers and returns a Boolean, true or false. So we'll say private static, and we're still going to return a list. And in this case, let's call it apply filter, right? And we will take the same inputs, so a list integer ints. But in this time, instead of an amount, we'll take an int predicate IP. Okay. Now, the first bit is the same, so we'll just go ahead and create our out. Integer out equals new linked list. Oops. And now we'll do the same thing for integer I in ints. If IP dot test I, so this is how an int predicate works. Effectively, an int predicate is a type of functional interface. Well, it's not actually a functional interface, but it is an interface that allows us to pass functions around. It's designed for that purpose. So then we'll do things, and out dot add I. Okay, and then we'll define our filter. So instead of out equals remove integers greater than amount, int 5, it's going to equal apply filter. Oops. And we're going to apply that filter to ints. And then we're going to make a new int predicate. And this will go ahead and, wow, it generated the whole thing for us. Okay, we'll add override it, but this just returns false. So instead, what we're going to return is value less than or equal to 5. And then we'll run it. And this should provide us with the same output. I did it again. No return. All right, now it should provide us with the same output. There we go. 0, 1, 2, 3, 4, 5. Yeah, sure, that'll be fine. So what's happened here is we have our int predicate, and it's already warning us, oh, we can replace this with a lambda. Well, yes, that's exactly what we're going to do here. So what this is doing is it's making a new int predicate. So int predicate, let's go ahead and just see what it would look like if we wanted to implement a whole int predicate, because there's only 4 functions in it. So we'll say private class IP extends int predicate. Whoops. Extends? No, we would want implements int predicate. And I think this will let us, yes, implement all the methods. So there's only 4 methods in this. There's test, and, negate, and or. And, negate, and or are for are for chaining int predicates together. In this case, you don't really need to implement those, don't need to worry about it too much, but if you were to say int predicate and some other int predicate, then it would return int predicate, or IP1 dot and IP2 would return effectively test, or IP1 dot test and IP2 dot test. They're just for chaining things together, and they don't really matter too much for our purposes because we're going to replace it entirely with a set of Lambda functions. So we'll leave this up here for the moment, comment it out, so you can compare and contrast. So if we wanted to do this with instead a Lambda function, remember apply filter is taking some int predicate. A Lambda function that takes a single input and returns an output that is Boolean is actually a valid int predicate. It can be cast int predicate without having to even worry about what's going on behind the scenes, at least for our purposes. So instead, we might say list integer out equals apply filter ints once again, but this time instead of making a new int predicate, we can use a Lambda function. This was not possible in Java 7, but it is possible in Java 8. I, for our input, maps to I less than or equal to 5. Done. This has exactly the same output. 0, 1, 2, 3, 4, 5. So what's happening here is this Lambda function, which takes in a single input and outputs, or a single, it's not defined necessarily to have an integer input. Behind the scenes, it's actually generic, but it can be cast to int predicate because it outputs a Boolean very clearly and takes in a single element input. So effectively, this code right here, lambda I maps to I less than or equal to 5, is exactly the same as this entire new int predicate. And behind the scenes, it actually does the same thing because the input type of apply filter is still int predicate. So lambda is a valid int predicate if it's set up this way. Now, if you were to say ij, then it's no longer valid because an int predicate, well, only takes one input. So it has to take one input. It has to actually map to the right type of function. So in that case, we have this Lambda function, but actually we don't need this entire apply filter thing anyway. There's already a bunch of filters available for us in the regular streams interface. So we'll go ahead and comment this out as a second method for doing what we want to do. So this is method, this is the second method basically. And the first method, I guess you'll have to go back in the video to find because I didn't actually think to do this beforehand. Method 3. And then method 4. And we'll go ahead and say list integer out equals, and we're going to use some ints dot. So we already have our int stream created and boxed into a list of integers. So we're going to use ints. We're going to stream it, and we're going to remove this later. I'm sure you can see how already if you have gone ahead and looked through the streams interface outside of these videos. So then we're going to go ahead and use the filter function. And if we take a look at what actually the filter function takes in as an input, it takes in a predicate of question mark super t, where t is the type of stream. So in this case, we already verified that I maps to I less than or equal to 5 is a valid int predicate. That means it's also a valid predicate. This is still a stream, so we're going to have to collect it, and we're going to use collectors to list again. Nice and easy. We'll run this. We should get exactly the same result. 0, 1, 2, 3, 4, 5. Now we don't need to box it into a list and then collect it, or box it, collect it into a list, and then make another stream out of that list. We can actually cut off a whole lot of this, so we'll go ahead and comment this out. And instead of ints.stream, we will just have the first bit of int stream, stream dot range 0 to 10 Don't need to dot stream it, so we just take the filter, and what's up? We filter it, and then we need to box it. And that'll do us. We can do it just like that. And of course, we don't even need to store this into some list. We can actually just do it right inside. So range 0, 10 dot filter I maps to I less than or equal to 5 dot boxed dot collect. So this is one way to do it, since, as it would appear, system.out can entirely handle lists, which is not what I had prepared, but we can go ahead and run that, and we should get exactly the same result, and we do. So if we wanted to actually join it together and just map everything in here, we'll say system.out.println, and we'll send this out here, intstream.range010.filter, .boxed.collect. So before .collect, we will .map, and actually we can do the boxing and the mapping in one step with, well, we'll get to that after we map it. So we'll map, and we'll use string value of, and then we can do the boxing and the mapping in a single step by using map to object string.value of. So a map to object in an int stream takes your primitive stream of ints and maps it to some object. It can map it to an integer, it can map it to any object as long as you pass it in some function. Whatever the output is, that's the type of string you'll get. Let me collect it. Instead of collectors.list, we'll use collectors.joining, and we'll go ahead and use our standby, comma, space, and then we've printed. Nice and simple. So this bit of code replaces all of this and half of this, and that's all we got. We can even remove a whole bunch of imports too, although a lot of those will end up being imported behind the scenes into other objects. This video did go on for quite some time, but I feel like we sort of managed to discuss how lambdas are used, at least in a bit of refactoring for Java 8, and how you would use them to clean up code that is fairly standard in Java, particularly the int predicate style system, or the sort of generic functional interfaces that you use. And you can replace that all with just Lambda functions. Really nice and easy, and it's very similar once it's compiled into bytecode, but it does actually use like 2 fewer instructions. I think it's 2. It might actually only be 1 fewer instruction, because it's not boxing the function twice, only once. But that's something that probably isn't going to matter for the vast majority of people. I hope you enjoyed this, and I hope it was helpful for you. Come back next time. Feel free to like and subscribe, and see you.